Okay, we're going to move on to something called stationary points. So that's stationary, not stationary. Stationary meaning something's not moving. Okay, so what's a stationary point? So a stationary point is a position on a function that has zero gradient. There are four types. Now we're going to sketch what those look like. The first is called, let's get rid of that. The first one is called a maximum turning point. Okay, so you can see that this curve has got a gradient which is going up, it then goes down, but in between it's got zero gradient just there. We call that a maximum turning point. So let's take that down, max TP, max turning point. Okay, then you've got obviously a minimum turning point. Then you've got something called a rising point of inflection. What that means is the gradient is going up, and it goes up again, but in between it's zero, so it's going up, it's going along, and then it's going up. So a point there, the gradient is zero. We call that a rising point of inflection. Sometimes you abbreviate that as RPOI. And then you've got a falling point of inflection. So that's when the curve is going down and it's going along and then it goes down. Okay, so we would call that then a falling point of inflection. FPOI. Now, one point to note is a maximum turning point. Before you get to a maximum turning point, a curve goes up, and then after the curve goes down. For a minimum turning point, the curve's going down, and then the curve's going up. For a rising point of inflection, it's going up, it's going along, and then it goes up. Falling point of inflection, it's going down, along, and then down again. Okay, so let's get right into it. We're going to try an example one. We're going to find the stationary points, so we can put that down as SP for short, on the curve. F of x equals 2x cubed minus 9x squared plus 12x, and I'm going to also do something called determine their nature. Now, what does that mean? We'll get down to that in a minute. That means, is it a max, is it a min, is it a rising point of inflection, or a falling point of inflection? Okay. Now, first thing to remember is we're looking for stationary points. Those are points of zero gradient. Now remember, when you differentiate a function, you get the gradient, so it's going to be 6x squared minus 18x plus 12. That is the gradient. Now, what do I know? I know that a stationary point is a point of zero gradient. So what do I do next? I make the gradient equal to zero. There's the gradient. When I differentiate it, I get the gradient, and I'm told that the gradient is zero. So what we do here is pick up a mark for communicating something to the marker, which is as follows. For stationary points, f dashed x, i.e. the gradient, is equal to zero, so it's important that you put that down. Okay, the next thing that I'm going to do is to factorise this. This is a quadratic equation. So first rule of factorising, take out a highest common factor, so it's going to be 6 bracket x squared minus 3x plus 2. I'm going to divide both sides by 6. That will bring me down to just 1 beside the bracket, which means I don't need the bracket. X squared minus 3x plus 2 is equal to 0. Two numbers that multiply give 2. Add together give minus 3 is minus 2 and minus 1. So now I've got x minus 2 is equal to 0, or x minus 1 is equal to 0. x equals 2 and x equals 1. Okay, so that's the x coordinates, the stationary points, and now we need to find the y coordinates. So we did a sub the x coordinates back into the original function. So let's do 1 first of all. F of 1, it goes into the original function, not the gradient function, the original function, because that's one that will get y coordinates. 2 lots of 1 cubed minus 9 lots of 1 squared plus 12 lots of 1. So that's 2 minus 9 plus 12, and that's 5. Okay, so stationary point 1 is 1, 5. Okay, let's now go after stationary point 2 by subbing in x equals 2. So that'll be 2 lots of 2 cubed minus 9 lots of 2 squared plus 12 lots of 2. Okay, so 2 cubed is 8, times it 2 is 16. 2 squared is 4, times it 9 is 36, plus 24. Okay, 16 minus 36 is minus 20, minus 20 plus 24 is 4. Stationary point 2 then is 2, 4. Okay, the next thing we need to do is to set up a nature table. Now, a nature table is going to tell me what type of stationary point is it. Is it a max? Is it a min? Is it a rising point of inflection? Or is it a falling point of inflection? So what that helps us do is to investigate the gradient in either side. So if it's a maximum turn point, we would expect the gradient to be positive before it and negative after it. If it's a min, we'd expect the gradient to be negative before and positive after. If it's a rising point of inflection, we'd expect the gradient to be positive and then positive again. If it was a falling point of inflection, we'd expect it to be negative and then negative again. Okay, so let's see how we're going to do that. Right, so we know that stationary points occur when x equals 1 and when x equals 2. So let's just create this table and talk through it. So I've got a table for x coordinates, I've then got a table for gradient, and then I'm going to have a table for slope. Now, then we need to put in what we call neighbouring values. Now, neighbouring values are points just before, just between, and just after the stationary points. So this first stationary point occurs at 1. So just before that, we could take our first neighbouring value to be, well, 0. Okay, so just before 1 is 0. Now, what about just in between 1 and 2? Well, that might be 1.5. And what about just after 2? Well, that might be 3. Now, we're going to investigate what happens to the gradient of the curve here, here, and here. Okay, we already know that the gradient of the curve when x equals 1 is 0, and when x equals 2 is also 0. Okay, so what happens when we look at the x coordinate 0? So we sub it back into the differentiated function. Now, why the differentiated function? Because this time we're investigating the gradient. So f dash 0, that's going to be 6 lots of 0 squared minus 18 lots of 0 plus 12. So that's 0 minus 0 plus 12. Now, the important thing is we get a positive result, so the gradient is positive. Let's now try it for 1.5. So at this point we'd use the calculator. Okay, so that's 6 lots of 1.5 squared minus 18 lots of 1.5 plus 12. Okay, now when I put all that in, I get minus 1.5. So the important thing there is that is a negative result. Let's now sub in 3. So f dash 3, 6 lots of 3 squared minus 18 lots of 3 plus 12. 3 squared is 9, times 6 is 54. Minus 18 times 3, that's minus 54 plus 12, and that'll give me 12, and that's a positive result. So what do I know then? Well, I've subbed in 0 into the gradient function, and I know that it's going up. So the slope goes up, and then at 1 that's a stationary point, a point of 0 gradient, the curve goes along. And then when x equals 1.5, the gradient is negative, so it's going down. and then it goes along again at 2, that's a stationary point, and then the gradient was positive again at 3. Okay, now that clearly shows me that I've got as a max, so a max turning point at the stationary point 1, which is 1, 5, and a min turning point at stationary point 2, which is 2, 4. Okay, let's try an example 2. Okay, so example 2, we're going to find the stationary points on the curve f of x equals 4x cubed minus x to the 4, and determine their nature. Okay, so first move is to differentiate. So what you should be doing at this point is just noticing the pattern from this question to the last question. First move is to differentiate, and what was next? Make the thing equal 0. What was next? Make the statement f dash x equals 0 for stationary points. Okay, what next? Let's solve this equation. So take out a highest common factor. From 12 and 4 I can take 4. From x squared and x cubed I can take x squared, so 4x squared. 4x squared times what gives me 12x squared? That's 3. 4x squared times what gives me 4x cubed? That's x equals 0. So I've got 4x squared equals 0. 3 minus x equals 0. X squared equals 0 divided by 4. X squared equals 0. Square root of 0 is 0. And then I've got minus x equals minus 3, and x equals 3. Okay. Now let's go after the y coordinates for the stationary points. Let's go into the original function to get the y coordinate. Let me sub in 0 to get going. So it's going to be 4 lots of 0 cubed minus 0 to the 4. That's 0. So stationary point 1 then is 0, 0. Okay, second one, f of 3 equals 4 lots of 3 cubed minus 3 to the 4. 3 cubed is 27 times that by 4 is 108, minus 3 to the power 4 is 81, and that will give me 27. So stationary point 2 is 327. Okay, I now need to set up my nature table. So I've got 0 gradient at 0 and 0 gradient at 3. Okay, and I'm going to investigate what happens before, between and after. So it's just before 0. Well, I could take minus 1, will be between 0 and 3, or I could take 1 or 2, it doesn't matter. So let's go 1. After 3, I could take 4. Okay, so then what I'm doing is investigating gradient, because I want to know if the curve's going up or down. So if I'm investigating gradient, I'm going to the differentiated function. So the differentiated function, let's just remind ourselves of that. That was 12x squared minus 4x cubed. Okay, so I'm going to put in minus 1, see what happens. F dash minus 1, 12 lots of minus 1 squared minus 4 lots of minus 1 cubed. Minus 1 squared is 1, 1 times 12 is 12. Minus 1 cubed is minus 1, times that by minus 4 is plus 4. That's 16, so the gradient is positive and the slope's gone up. Now at 0, we already know the gradient is 0, slope goes along. Okay, what about f dash 1? Okay, so it's going to be 12 lots of 1 squared minus 4 lots of 1 cubed. That's 12 minus 4, that's 8, that's a positive result. The curve's gone up. I already know what's happening in 3, that's a stationary point. Gradient is 0, curve goes along. Okay, what about x equals 4? So put it into the gradient function, f dash 4, 12 lots of 4 squared minus 4 lots of 4 cubed. Okay, 4 squared is 16, 16 times 12, that's 192. 4 cubed is 64, 64 times 4 is 256. And that will give me minus 64. That is a negative result. Curve is going down. Okay, so I can see what I've got then. That is a rising point of inflection. It's stationary point 1, which was minus 1, or rather, which was 0, 0. And that is a max turn point. Max turn point at 327.